Warahmatullahi wabarakatuh, and welcome to BMFG4623. Today we will talk about combining factors. This is our chapter number 3 for engineering economics portion of the subject. Right. So the learning outcome for today is to use multiple factors to find equivalent amounts of cash flows that have non-standard placement. Right, so we will witness that in the cash flow, the placement of the values of the monies are non-standard. First of all is we want to determine what is P, what is F, and what is the A values for a series starting at a time other than period 1. Number 2 is to determine the value P, F, and A at a shifted series that is randomly placed in a single cash flow. And number 3 is to make equivalence calculations for shifted arithmetic and geometric gradient series that increase in or decrease in size of cash flow. So we have here an example of shifted uniform series. Why it is shifted? It doesn't start at number 1. It starts at number 2, or it could start at other numbers as well. Right, for this example, we start at number 2. So the cash flow diagram below is an example of shifted series. The shifted series usually require the use of multiple factors. So we not only use one factor, we use more than one. Okay, so what do we see here from the cash flow diagram? We have the value 0, which is ultimately, this is where the P is. Okay, P at 0. We do have P at A over here, which represents the value, the present value of A that starts at number 2. And we do also have the values of FA, the future value of A. However, there's two things that you need to remember when we study about shifted uniform series. Okay, when we use P of A or P factor, P of A is always 1 year ahead of the first A. Okay, it's always 1 year ahead of A. So, for example, in this case, A starts at 2, so P has to be a year ahead of time. So it has to be at number 1. Okay, if A starts at 3, so PA will be at P2. If A starts at 4, PA will be at P3. That's what it means. Okay? It must be 1 year ahead of the first A. So on the second condition that you have to remember, when you use F of A or A of F, FA is in the same year as the last A. Okay. In this example, we have A finishes at n equals to 5. So at n equals to 5, that's where FA is situated. If n equals to 4, then FA will be at n equals to 4. We can always write it FA at 4 here. Okay, so it depends on the situation of the questions. So now we have an example of P over A factor, shifted uniform series. Okay, present worth of the cash flow shown below at I 10% is, okay, you are asked to find the present worth. What is present worth? Present worth means P at P equals to 0. If you realize that now P is pointing upwards, not downwards, if P is upwards, F is always downwards. And F finishes at n equals to 6. Okay. How to solve this equation, this problem? First, we must use PA factor with n equals to 5 for 5 arrows, 1, 2, 3, 4, 5, to get P1 in year 1. Okay, you must get the P1 first. P1 at 1 here. And then use the PF factor with n equals to 1 to move P1 back to P0 in year 0. So it comes down to P0 equals to P1 times P of F 10% period equals to 1. Okay, this is what P1 is. But how do we get the value of P1? Okay, to get P1, okay, we must multiply A with the present value of P over A. I at 10%, n equals to how much? How many? 5. Okay. So when we have P1, we get the value at P1. To solving for P0 is equals to P1 times P over F 10% at n equals to 1. Okay, now we want to solve for P1. Okay, equals to how much is A? A is 10,000. And then you want to find PA 10% at n equals to 5. You get a figure, which is actually 3.7908. Okay, this is from the table. Okay, you get a value of how much? X. Okay, then to get P0 equals to P1 times X, and you got the answer of 34,462 ringgit. Okay, this is easy, isn't it? Right, good. Good. We do have another example that is you can use to find the present worth value of the cash flow shown below at I equals to 10. So how do we solve for this? Okay, we find P0 and then P at 3. So P0 equals to P3 times P what? P3 times P of F, right? Interest 10%, n equals to 1, 2, 3. Okay, so how do we solve for P3? P3 is equals to A times P over A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n A equals to 10. Okay, 10%. A equals to 10. And you get the value. So 50 times X. And now you solve for P0. P0 equals to P3 times PF. Okay, find value of PF and you should get the answer. Okay. So we have more example of using P over A factor, shifted uniform series. Okay. You can use the same method and try to solve for this equation, this problem, okay? So now, you want to move on by using f of a. Okay, previously we used a lot of present worth value. Now we want to use the future worth value of the shifted uniform series. Okay, how much money would be available in year 10 if RM 8,000 ringgit is deposited each year in years 3 through 10 at an interest rate of 10% per year? So the money came in at year 3, okay, until 10. Okay, and the interest rate is 10%, A equals to 8,000. Okay, they want to know the future value of the money if $8,000 is deposited. Okay, so you, in the cash flow diagram, okay, it is good to renumber the diagram to determine the n value, the number of arrows. So we always start at n equals to 3. This is the actual number. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But since it starts at year 3, so this would become your year 1, year 2, year 3, year 4, year 5, year 6, year 7, year 8. So how many periods do we have? 8 periods. Okay, so the n for you is 8. I for you is 10%. Okay, A value is how much? 8,000 ringgit. So solving for this, you have F equals to 8,000, which is A, times F of A, 10%, n equals to 8. And you get the answer. Okay, this is A times F of A. Okay, solving for this is actually F equals to F of A times A. Okay, fair enough. So now we have another example of shifted uniform series. You have a recalibration of sensitive measuring device cost at 10,000 per year. If the machine will be recalibrated at each year of 6 years, starting 3 years after purchase, analyze the 8-year equivalent uniform series at 10% per year. So after the 3rd year, you have 6 years of recalibrating. You want to recalibrate it. All right. So from year 3 onwards, the machine will be recalibrated. Okay. So the question asks you to analyze the 8-year equivalent uniform series at year 10. Analyze the equivalent uniform series. Yeah. All it is asking is the value of A. They want the average value of A the moment it starts from year 0 to the year of n equals to n. N equals to 8 over here. So a hint, you can use either P of A or F of A relationship for shifting, and you can try to compare both approach. It should come with the same answer. Okay, next, we want to talk about shifted series and random single amounts. Okay, for cash flow that include uniform series and randomly placed single amounts, uniform series procedures are applied to the series amounts, and single amount formulas are applied at the one-time cash flow. Okay, this will result of combination of uniform series and single amount series as per the problem statement. The following slides illustrate the procedure. Okay, example for series and random single amounts. Okay, the question says find the present worth in year 0 for cash flow that shown using an interest rate of 10% per year. Okay, so what do we have here? We have 2 sets of series. Okay, the first series is an A series. Another series is a single series. Okay, so the A value is 5,000 ringgit, and the single amount value is 2,000 ringgit. So what do we want here? We want to find the P total at P naught. So how do we solve for this? Okay, the solution. First, we need to renumber cash flow diagram to get n for uniform series n equals to n. Okay, from here, from the cash flow diagram, we can see that A starts at n equals to 3 for 8 periods. So 1, 2, 3, 4, 5, 6, 7, 8 period, which is in the actual years is on the 10th period, n equals to 8. So, okay, and then use P over A to get PA in year 2. Okay, you want to get PA so that you get the value of the series over here. And then move PA back to year 0 by using P naught equation. Wherever you get the answer here, you multiply with P over F here, and you get the values. And then move single amount back to year 0. Okay, P 2,000 ringgit. You can get the P equivalent at P naught equals to 2,000 times P over F, 10% at n equals to 8. So 2,000 times 0.4665, you get a figure of 993. So to get the P total, you have to add up. Okay, whatever you get, PF times PA, which is 22,044 ringgit, plus the value of P single value at P8. Hence, you summarize everything, you just add up both values and you get this. Okay, easy peasy, lemon squeezy. So, example of worked a different way. Okay, we can also use the F over A because just now we used P over A. Now we can also solve this using F of A. So the same renumbered diagram from the previous slide is used. Okay, PT is here, and n starts at 3 until 10, which is renumbered from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the first solution is find F of A in the actual year for 10. So FA equals to 5,000 ringgit times F of A 10% and equals to 8. Okay, remember 8, yeah, not 10, because your interest will be on the A series, and the A series only happens in 8 periods, not in 10 periods, not in the total timeline. So the value is 57,180 ringgit. And then you want to move back FA to year 0 using P of F. Okay, so now you have the values here times P of F, 10% year 10, 57,180 times 0.3855 equals to 22,043. Move 2,000 single amount back to year 0. Move single amount back to year 0. Okay, so what do we do? 2,000 times P over F. Okay, 2,000 times 0.4 0.4665 and you get 933. And now add two p values at p total to get p total, then you get the same figures, same as before. So as shown, there are usually multiple ways to work on this kind of problem. You can either use the first way of using p, or you can either use by using f value, and the answers should be the same. Okay, move on to example series and random amounts. Okay, we have a cash flow diagram over here, and we want you to convert the cash flow diagram, okay, the black arrows, into an equivalent annual worth A in years 1 through 8, okay, into 8 arrows. Okay, we want to know how much the value of A of the first 5 years distributed to the next different cash flow of n equals to 8. Okay, how to get this? First approach is to convert all cash flow diagram into P in year 0 over here. Yeah, this is year 0, using A over P with n equals to 8. Secondly, find F in year 8 and use AF with n equals to 8. Okay, solving for F first, we have to find F first, then only you can convert to P. Solving for F, F is equivalent to the value of A, 3,000, times F of A here. Okay, 10%, 5 periods, plus the value at here, n equals to 7. Okay, 1,000, F of P, okay, 10%, 1. Why is it 1? Because between 7 and 8, there's only one period, the point of reference you use for F. Okay, because n over here is only 5, you use this as your point of reference. So thus, n for F of P of $1,000 is actually n equals to 1. So 3,000 times 6.1015 plus 1,000 times 1.1. And you get a total amount of 19,415. This is the amount of F at the end of here. So how do we get the value of A? Okay, find A is by multiplying the F value, okay, over A of F. Okay, this is how you get A. So from F value over here, 19,000, times A of F, okay, 10% for how many years? For new A. For your new A will be 8 years. And therefore you get 1,698. Okay, now you can see that from the values reduces, okay, as we drag the timeline. Okay, example of series and random amounts. Okay, this is one example. Akramim plans to have $100,000 10 years from now. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which the rate of return is 10%. Analyze the alternatives to achieve the above target. How much deposit now in year 0? Okay. Okay. Akramim wants to have $100,000 as the future value. Okay, in year equals to 10. Okay, so how much he should put in the money as deposit, P naught. So P not equals to F over P over F at 10%, N equals to 10. Okay, and yearly deposit, if he starts invest now, okay, he wants to find A until year 10. If he invests only from now, so yearly deposit, find A if he want to invest 5 years from now. So his investment starts from year 5, 6, 7, 8, 9, 10. Okay. And yearly deposit if he plan to invest from now to 5 years. So it's from now 1, 2, 3, 4, 5. Okay, these 5 periods. Okay, question number 3, these periods. Question number 4, these periods. So you can easily count it using the examples I've given you previously. Okay, now we have series and random amounts again. Another question. Okay, an engineering consultant company in Aikro that owns a sizable amount of land plans to lease the machineries to a company. The contract calls the company to pay 20,000 ringgit per year for 10 years, beginning 3 years from now. For example, beginning of the year 3 and continuing through year 12, plus $10,000 3 years from now, and $15,000 8 years from now. So we have, okay, so many random amounts of money. So utilize engineering economy relations to analyze the 5 equivalent values listed below at 10% per year. So this is the question. You can use all the equations I've forwarded to you, I've explained to you previously to solve these questions. Okay, if you look at these questions, the question like this and like this actually these 2 questions looks like your midterm and your final questions. So it is good for you to do more exercises on a real life cases like these, because your final and your midterm will look exactly like this with real case scenario. Okay, now we stop.